For our next technical session, I would like to welcome Mr. Alok Bhaumik, Managing Director, BNS Engineering Consultants Private Limited and Advisory Board Member of Seismic Academy. Please join me in welcoming Mr. Alok Bhaumik to chair this technical session. For this technical session on case study, the first speaker is Mr. Arunava Bhattacharya, Manager Design, CDC Technical Services Private Limited.
Good afternoon, everybody. Good afternoon, sir. Building retrofit, a 16-letter word, but it involves so many brainwaves and intricate engineering solutions. I'm going to present you an industrial case study of building retrofit. It evolves out of the urge of industrial expansion in spite of having very severe space constraint. So there is going to be a slight change to your taste buds after listening to such engrossed and wonderful discussions on seismic retrofitting. Chambal Fertilizer, the leading fertilizer producing company in India, wished to expand their production at their site at Kota, Rajasthan. And the most challenging structure amongst that project was the bagging house. So I'm going to demonstrate some of the examples of that. This was the present scenario. This was the then scenario at the initiation of the project, where there were two columns, RCC columns, and one shade above. It is creating the platform over here. And so same thing on that side also, and in between the two there is these locomotive lines which are already live. This is the plan. Previously that was a section. There were 4 grids, E, F, G and H. Between G and H there is an existing shade platform as well. And between E and F there is another one, and in between two there are 2 rail tracks which are live and rail is running by it. This is the picture. You can see these columns. These are the columns at grid E, F, G and H, connected with some thin beams, one at top and one at this midway, somewhere midway in this level. This is also an example of the existing facility which was there. Now what was our objective? Our objective is to create a RCC bagging building using this existing infrastructure and providing some interconnecting corridor across this 14.5 meter wide railway track which is there over here between grid F and G. Now, what is the proposed scheme? The proposed scheme was like this. Then in between this E, F and G and H, there will be interconnecting corridor above, giving way to a platform and additional conveyor to feed this bagging house. This bagging house is a completely RC structure, 25 meter height, which is getting supported from this existing column H. Now between this grid E and F, this is the elevation along grid E and F. So these are all existing columns which are 12 meter apart. Okay, and there will be interconnecting platform over here, and above that one shade has to be erected, structural shade. Now one thing has to be mentioned that these columns, though the columns are having at a spacing of 12 meter center to center, but we cannot provide one shade with a 12 meter span. For that we have to go for an additional column in between to take care of the stability of this overall shade. Now you can appreciate that once we are going to provide one additional column over here, this is an existing beam. So beam will deflect more, it may fail during the design. So what we have conceptualized is that taking the effect of the two beams and providing some girder-like arrangements in between, we will provide a girder which is having more rigidity than the individual beams, so that it can take the load of the shade above. This is for the grid F. That was grid E, this is grid F, the same thing. Now, let us come to grid G and H. Particularly in H, from H onwards, H, J and K, this is the area where we are going to construct our new bagging building. Okay, this J grid is the new one, K grid is the new one, but the H grid is the existing one. With the help of those existing columns, we have to erect this, we have erected this bagging house, a 25-meter high RCC structure. So in the course of doing so, what we have to thought for that for 12-meter span is getting to be a very heavy for the beams and columns for this bagging house. So we have provided foundations and columns in between the existing one column, so that the span becomes 12 by 2 means 6 meters, so that this column can be easily designed and beams can be easily designed. This is the elevation, entire elevation of this bagging house. This is the long elevation and this is the cross elevation. You can see that up to this point there was the existing structure is there, and above that it has been erected up to this height. It is totally 25 meter right from this 9 meter level to 34 meter level. Now there were some challenges. First is that new conveyor line has to be erected above a live traction line. Second is that grid H existing RCC columns which are to be used, which have to be used for the new bagging building. And the third and most pertinent point is that we have performed the NDT test, and that test indicated severely reduced concrete grade due to the chemical exposure. These are some of the structural analysis. This is for grid E and F with the existing columns, interconnecting corridor and the shade above. And this one is for the bagging building, the entire structure with the existing columns, beams and the connecting girders. So in these cases, what we have to done, especially in grid E and F, where there is much load to come, only the shade and the interconnecting corridor, there we have not given any additional column in between. Instead of that, we have provided this girder-like of facility and erected the platform and the shade above with the due consideration. Now in this process, these columns are to be strengthened, and at the same time the foundations underneath that also has to be strengthened. So these are some of the schemes of the columns having the strengthening procedure. This was the inside was the dotted line was the core column, and some additional inserts. We have provided this outer periphery of column of 800 by 1000 millimeter size to take care of the loads coming from the above. And then in the same way, this dotted line indicates the original foundation, and this has to be increased on both the sides with the Hilti anchors, requisite Hilti anchors, to get rid of this solution. Now here also there is some challenges, because the existing beams were very less in thickness. These beams, I don't know, they have been probably given for the lateral stability of the columns, not to take any horizontal, not to take any vertical loads. Because this beam is of 400 millimeter depth, this beam was only 500 millimeter depth. with this 500 and 400 we cannot take the support from this beam, so we got this kind of girder-like arrangements, and with that girder-like arrangement we have been succeeded to cater for whatever loads coming from the new facilities on the structure. There are some of, this is a typical connection at the bottom of the beam where the girder has been made. So the main thing of this one is that we have not given any hilty bolts or anchors from the below of the beam, because I don't know exactly what was the grade of the concrete there and how the bondage will come over there. So instead of that, what we did a C type of plate and anchored it with some through hilty anchor bolts, so that whatever tension will come, that tension will not come in the form of tension but in the form of shear, which is more safe. So this is the finished facility. This is inside the interconnecting corridor. This has already been completed. This is also a finished facility inside the connecting corridor. This is the bagging building, which I was talking of so far. This is the longitudinal bagging building. One conveyor is running from over here, and this is the cross section. These are the two new columns, and the existing column was somewhat here, over here, which we have retrofitted and doing the construction for the rest of the things. So the project stakeholders, the client was Chambal Fertilizer, client's consultant was Toyo, contractor was ThyssenKrupp Industries India Limited, and we are the consultant to the contractor, CDC Technical Services. So it has started in the year of 2016 and get completed, went live in the year of 2017, and this is 2025, almost end, so it is working fine. So great round of applause for the Hilti people who were beside us. They have given all the kind of cooperations, all the kind of knowledges that they have, advices that they have, so that we could step forward side by side and get the success for this completion of this project. Thank you.
Excellent presentation. Thank you very much. I think a classic example of how industrial structures can be retrofitted. And I think these kind of examples should be well publicized in different journals, so that people because these kind of problems come often, yes. And the designers many a times do not have a side of examples to refer to. So therefore, I think my suggestion would be that you must publish these case studies in some journals, and so that people are aware of it. Sure. So I think now I can open this floor for any questions. 2 questions, okay? So, yeah. Dr. Dhawan.
Mr. Bhuvik, you exactly said that we need some more case example published, just for the benefit of all the CPOD, with the help of Engineer K.V. Rajoria and by the helpmate Srivastava, has written a book on project management, where they have given the explanation of more than 100 projects, new as well as the retrofitted. The retrofit example of the present Secretariat building now being occupied by the government, it is a retrofit project. So I would suggest that the book costs only 300 rupees. Every one of you should buy and have that copy. That will give you enough level of knowledge and strength to know what is actually project management.
Yeah,
this is what
I think I cannot agree with you more, because I can tell you that future for civil and structural engineers is retrofitting, asset management, and therefore I think if you want to be in the market and survive, I think you have to get into this repair, rehabilitation, retrofitting kind of jobs.
Even our technical guide, written by our great man, published through Indian Association of Structural Engineers, so it contains 10 pages, is also again a valuable document for the young people.
Yeah. So, any other question from the audience?
Any difficulty that you faced in this process of retrofitting?
Difficulties we have faced actually during the construction of the foundation, especially because the locomotives were live then.
People will be willing to know what are the difficulties that you faced during the process.
And that not only difficulty, but lessons learned. Lessons learned also, just 5-6.
Actually, I was for the design part, so I went to site once or twice. But what the actual difficulties have been faced by site, that site people can tell you better, but not me, actually.
Yeah.
That
so
I can say.
What is the seismic zone where this project is?
It was zone 2.
Zone 2. So seismic is not
Seismic was not the criteria.
was not a matter of concern here.
This is what the normal loading was the criteria.
Okay, okay.
So I was worried because
Yes.
the direction, the stiffness was not adequate enough for the higher loads.
Exactly. So,
I think that's the last question for this.
Sir, maybe just I can add because I was also involved from day 0 of this, and in terms of the difficulty that you asked, you saw the project was very much centered around, I mean, when we defined the retrofitting, it was also a lot of anchoring involved. The bracings and everything had to be done with a lot of anchoring, and it was mentioned that the concrete was also not very, in a very great condition. So we also had to minimize the damage to that. So if you had seen one of the drawing specifications, so while we went for through bolting in a lot of cases so that we have minimum drilling in the structures, we also did not want like multiple drill points also because of that. So there was some specific equipments that we used that was not very commonly available in India. That's called a transpointer device. Even in India today, it's only one piece that is available. So it's very specifically designed for a through bolting. So you have a receiver on one face and a transmitter on the other face. So you first scan one surface, you map the reinforcement profile, then you map the drilling points, you take the receiver on the other side, and when all the lights are green, you then map that particular drilling point on the other surface. And then you further scan the second surface. So once everything matches, you know your drill point is straight. So that is how we also try to minimize the intervention in the structures, because it was all working on an existing concrete which was not very suitable. So that was one of the efforts that we also tried to take care from the design perspective, and touchwood execution went very seamless.
Good. Thanks for this clarification, Shaunak.
thank you.
Hello, sir. Sir, one question, please. First of all, excellent presentation, sir. Thank you for the knowledge. You mentioned that you installed some columns for the shed to break the span of the structure, maybe. So the span, if those columns would not have been installed, then span would be around 12 meters?
Yes, 12 meters.
So was there any possibility of that you could have made the truss or the purlins heavier, or some other possibility that only 2 columns would have been constructed?
In the process,
what was the challenges that you were faced?
In the process, what becomes that your existing columns will extract more load, which I don't want to do. Okay, I want to give my existing columns as minimum additional load as possible, because of the grade of concrete is so severe and all those things. And even after doing this retrofitting work, I don't know that. See, when I have designed the column, I have to check the sufficiency for the column design. So what I have done, that for the moment capacity, I have taken the same core dimension of the existing column. Okay, but for the axial load, what has been enhanced due to that erection of this 25-meter old high structure, for this axial load, I have taken the effect or advantage of this increased column. My basic criteria was very simple, that give the existing columns as much less load as possible.
Okay, my only concern was because in current procedure you had to drill a lot of holes and the bracing had to be installed.
Lot of
In
drills,
that may have been avoided.
Lot of drills has to be installed, but those have to be installed for erection of the connecting corridor, that platform. For that beams, you need lot of holes. Okay. Now for this additional column, you will have to have 4 more additional drills over the beam. So that's it. For every 12 meter, you need 12 more drills.
Thank you.
Okay, thank you, Mr. Arunava, for this excellent presentation.
Thank you, Mr. Arunava Bhattacharya, for that very interesting case study. And yes, I understand case studies bring a lot of insightful questions, and you can definitely get in touch with him if you have more. For our next case study, I would like to invite on stage Mr. Rohit Yadav, founder and CEO, Texel Consulting Engineers.
Good evening, everyone. Being the last and probably the youngest speaker, I know it is not easy to pull your attention to the screen along with so many great sessions. But I am confident that a few next slides and the theme I have chosen, revive before replace, definitely will make your time worth. And in recent days, we have seen many structures collapse across the country. Each of them remind us of one thing, that despite we are talking about the new building new one, any one of them can revive to serve for more period. So let's talk about the today's agenda: conditional assessment, retrofit, and maybe the power of giving second life to the structure. So my theme is basically revive before replace, and in fact collapse as a conditional assessment. So I have 2 parts. One part is that of the theme of that Seismic Academy Conference, and the second part I would like to highlight. I requested to the organizers that I am involving one of the prestigious projects. So there has been site-specific spectra study was done. So I would also like to highlight the result of that site-specific spectra. So for first part, basically this is the line which we use to that we care our civilizations, we rehabilitate structures and make them safe and sustainable. So under this philosophy, for this segment, we are doing projects in our company. So let me introduce very quickly what is about conditional assessment. Maybe everyone is aware about the process, but it is very simplified process which can be understood by any of the engineering stream person. So I categorized into the 3 parts. One is that inspection, testing, and modeling. So under the inspection, that means what kind of structural system is there. We can expose the components, we can have the as-built drawings, and we can take the measurements to the site. Then testing of the material specifications through non-destructive and semi-destructive tests. So there is a list by which you can just get the data from different entity test, semi-destructive test. And then we have modeling part, that means define the position of structural systems, cross-section of the materials, and define the material property. So this is the process of structural conditional assessment I found. And then there is a analysis and decision of revive either or defunction before collapse. So we can reach to the conclusion whether we can revive the structures. In revival, basically there can be anything with the repair and retrofit of minor crack, major crack, minor imperfections, beam strengthening, slab strengthening, and many more. So this is the overall scenario of conditional assessment. So before starting, let me tell you one misconception. Basically, this is the real pictures where I did one retrofitting work. So before I entered into the project, I found that there is a deterioration into the column. In my second visit, I found that it has been plastered already. So it is very big misconceptions that repair means cover the cause of problem. It is very temporary. So reality is, it is not something about hiding the problem. It is like root causing the things and repairing whatever the problem is there. Then it will be long lasting. So again, I categorized 6 reasons broadly. Maybe there can be many different reasons, but as per like my experience, I categorized into the 6 parts where you need the retrofit or repair work or conditional assessment work. So first part is that poor quality of construction. So there is very basic pictures I took from one of the public facility. There is a infrastructure city park in Jaipur, and just I walked in the morning and I found that there is accumulation of rainwater. So this is the basic challenge. There is accumulation of rainwater. It doesn't seems to be the structural problem right now, but let's say after several years or 5 years, 10 years down the line, this dampness will cause the definitely corrode the reinforcement under this slab. So it is very basic detailing that under the poor quality of constructions, maybe material issue, execution issue, lack of awareness, lack of resources can be the part of. In second picture, you can see that there is a deficiency in casting. So to meet out these criteria, we need the conditional assessments and the retrofitting work. So this is the first reason where we put under the poor quality of construction. Under the second, like functional use, so I just made a basic sketch. It is more or less bit similar to the last case study kind of things. So there is a workshop where 25-ton capacity gantry was there. So they want to increase the gantry capacity to 50 ton without hampering the function. So basically, what I did, it is very simple that we just put another steel column along the RCC columns. To divide that effective length of that columns, we put a intermediate truss to support that truss, and intermediate bracket system, we erected another columns, and to reduce the effective length of that girder, gantry girder, we just braced into the steel sections, and it is the real picture of the site where we every case study has a background that of complete process, getting data, analysis and everything, but I am just giving the inputs of each function, like change in plan and purpose. So third one is that expansion of structure. So in retrofit, you need in case of like expansion of the structures. So this case study belongs to the one of a project in Jaipur, National Institute of Ayurveda building. So 150 years old building were there. So we made a steel structures over there by retrofitting the lower structures by using the steel columns, providing new bracings and all. The fourth one is that time-dependent degradations. The fourth reason is time-dependent. That means maybe due to the poor quality of more than one reason can be there. So due to dampness over the long period, there is a column which has been degraded, and as you can see, there is a bad plate of stone masonry pier with slab system bridge. This beam and slab has been degraded. Later on, we did retrofit with the RCC jacketing. Then fifth reason may be under-designed structures. So this is the picture of water tank facility in IOCL campus, Panipat. So we invited for the just the structural audit of the water tank. So we found that we made analysis in STAT point. We found that the longer section of bracing part is failing in slenderness ratio. So what we did simply, we just introduced another bracing highlighted into the red circle to make them less slender. Sixth one is the and it is very best way to ignore the incidents. In September 2023, there was accident in Chennai. IOCL canopy was collapsed. So after that, IOCL made provision into the company that every canopy which has been 20-year-old should be inspected on a periodic basis of 5 years. So we got the assignments. Personally, my team inspected more than 1,000 canopies. So this is the best way to ignore the accidents as well, like routine maintenance. So this is the sixth reason where we need to do the conditional assessment and retrofit work. And I searched also after these collapses of bridges, and one school roof has been collapsed in Jhalawar district, Rajasthan basically, and 26 kids were killed. So I found that there is no codal provision till so far that guide anybody to check the structure's frequency. So this is the way that Indian bodies to implement some codal provisions to maintenance like the individual companies which IOCL have done. So these are the broadly 6 reasons. Apart from that, I have gone through one another structural assessment to check the quality of construction as well as the structural design deficiencies in Dahidweep Jain Temple, Indore. So there is a large dome structures. We went there and we measured, verified the structural systems and made the models and did the conditional assessment. Later on, we suggested for some retrofitting as well. And another project I did that the expansion of services into the television tower. It is located in Bundi, Rajasthan. So basically, there is a requirement to enhance the antennas over the steel structure. So it is very large structures of 150 meter height, 110 meter of RCC section and 40 meter of steel tower. So we modeled into the STAD Pro and we found that it is not adequate to enhance the capacity of antenna and all. So these are the broad regions where we have to do the structural conditional assessment as well as retrofit work. Apart from that, quickly I'll brief the one case study. Graphically, what is the, just 1 second. So there is issues that corrosion of steel, definitely many, each of half of RCC structure is one issues, durability issues, that corrosion of steel, cracks in concrete, and unavailability of drawings, definitely. Whatever the conditional assessment I am taking, that many of them doesn't have the structural drawings with them. And definitely if drawing is not there, so material specification is not there. So what we did, that same process which I have shown into the flow chart, that measurement of the members, collecting the information, assessment of the material specification, and then 3D modeling analysis and design solutions. So all these are the process we have done. So we made the drawings. Do not go through the drawings. I'll just directly brief what we have done. So it is a masonry structure with 2-floor masonry structure with the slab. So this is the existing structural systems. What we did, we just introduced the peripheral large kind of foundation or plinth beam, you can say, like 2 feet wide and 2.5 feet deep, and made the steel. So basically, we introduced this masonry structure with slab system is a C-channel type portal frame inside the structural system. So here is the steel frame, beam, and then the purlins over there. And I'll show you this is the condition of slabs. We analyzed the slab as well, so the diameter has been reduced significantly. So based on that, being a structural consultant, we assumed that the remaining strength is taking care by the remaining part of the slab and steel is available. We can go with other techniques as well. It is totally depending on the structural engineer. I picked this method. Maybe some other will pick another method. So here is the type of plinth beam we introduced, and here is the picture of the steel frames and purlin system we did into the frame, and there is a very finished floor usable admin block into the school building. And the same case study I have already published in the earlier version of Seismic Academy Journal, I think 2 years back. So another thing I would like to highlight, that one of participant highlighted that the verification at the time of material arriving to the site. So I would also add something, that verification after strengthening. Basically, Our retrofitting is somehow based on some assumptions. And let's say there is one who is designing at the office and one who is executing at the site. So sometimes let's say drilling is there, so rebar is there, so जो ड्रिल कर रहा है उसको लग रहा है कि बस ठीक है हो गया. सो देर इज़ नो मेथडोलॉजी वेदर इट इज़. एंड जनरली जो इस तरह की रेट्रोफिटिंग बोल्ट्स है वो AM रोड से होती है, जैसे कि तो ना उसको कटिंग करके लगाते हैं, तो ऐसा भी नहीं है कि वो इतने का था तो बाहर इतना बच गया लाइक दैट. सो देर इज़ नो मेथडोलॉजी हाउ टू वेरीफाई आफ्टर एग्जीक्यूशंस. Till that, definitely there are some supervising system, but still there is a lack. Maybe in some literatures I studied that after inspection and repair of that Morbi bridge has opened to the public and still वो fail हो गया था. मैंने सिर्फ पढ़ा ही है, I did not find anywhere that कि तो मैं इस चीज़ का advocacy कर रहा हूँ कि after retrofit one should go for the verification test, and the best methodology to verification test is the full load test. I used to verify whatever I strengthen just by the full load test to the structures. So there is a slab where we did retrofit. It is in Mehendipur Balaji temple, maybe you heard the name, in Rajasthan. So we just strengthened the slab and we verified the slab just by putting, after all the designs and all, after putting the live, whatever the IS 456 simply suggested, that the live load and dead load combinations and measuring the deflection and elastic recovery of the slab. So we verified there is a dial gauge under the girder, and then we put the loads and just recover the, and we found that there is 2 locations we performed, and at one location it is 90% recovery, at other location is 76% recovery. So simply the code suggested that 75% is okay, but still I want to inform one other thing as well, that there were 2 locations where we checked the deflections, and at the location where the deflection recovery is less, बाद में पता चला कि कुछ मार्बल में बहुत हल्के क्रैक्स भी आ गए थे. दैट मीन्स देर इज़ ए परमानेंट सेटलमेंट ऑफ दिस. सो इफ लेट्स से मेरे वेरिफिकेशन में ये 50% आता, so that means there is deficiency in my retrofitting. So I need to take care of some other things. Maybe I defunctions the slab. कुछ भी आप decision ले सकते हो. But still you can avoid the tragedy which is going to happen nowadays across the country. Apart from that, the second part is that the site-specific spectra, whether it is a conservation or it is a safety. So definitely, I think so in last Seismic Academy event, one presentation was there. So एक साइट स्पेसिफिक स्पेक्ट्रा के लिए ऐसा था कि अगर आपको कम मिल जाता है तो नो वन इज गोइंग टू साइन टू यूज दैट द मिनिमम असाइंड इनटू द कोड. सो कंजर्वेशन इज नॉट देयर, बट सेफ्टी इज देयर जस्ट बाय I am involving as a structural expert into one of the project. So this is basic concept and significance of the site specific spectra everyone knows, and the project is basically this is the evaluation process and importance of site specific spectra. Let me come to the point. So there is a Skywalk is going to be built into the India. It is now under construction basically. So it is a very prestigious project. It's a 250-meter glass walk bridge with 93-meter high pylon. So we went for the site-specific spectra for that site, and we found that these are the process where we did, and we found that the peak ground acceleration is 0.47 g, and specifically the site is into the zone 4. So the code suggested that standard PGA is 0.24 g. Instead of that, we found that the site-specific spectra is 0.47 g. So it is more concern about safety. It is not about conservation, but it is about safety. If someone who is designing with the standard codes, then he will design with the 0.24 g. But here is the reality is that 0.47 g. So for the important structure, this is my recommendation to all that we need to go for the site-specific spectra. So this is all about today's presentation. Thank you. If you have any query, then I can take.
Thank you. Thank you, Dr. Yadav. I think you have covered a very large canvas of sharing your experience on several repair, rehabilitation and retrofit projects. And also you have given some idea about your site-specific spectrum study which you have done in one project. This is in Delhi? This
Skywalk.
Skywalk?
Sikkim.
Sikkim, okay.
It's at
So-
10,500 feet altitude.
Yeah, yeah. So, firstly, I only have one comment on your presentation. That is, you know, these three terms are totally different: repair, rehabilitation, and retrofitting. These are three different
Yes.
things, not the same. I mean, many places I found that you are using the word retrofit for rehabilitation, but in some of the presentations you have also shown the cases where the retrofit actually fits in.
Yes, yes.
So, but on the whole, I think you have covered a very large canvas, covering your experiences in various type of projects. I am amazed to see, you know, the kind of projects that you have done: temples, TV tower audit, as well as some industrial structures. Amazing. So, any questions? I think we can take. How many questions we can take? 2 questions. Okay. Yes, Professor.
Very nice presentation, Dr. Yadav. Really appreciate the number of projects that you have worked. In your second project that you have shown, where if you can quickly go to that slide, there you have shown the improvement of carrying capacity of a gantry girder.
Yes, yes.
And you have shown a hand-drawn sketch, very nicely drawn, as to what is the scheme you have adopted therein, where you have put the one beam, and then on that there is a column. The reaction of the beam is going to the ground adjacent to the reinforced concrete column, and it is supporting the reinforced concrete beam on the top. It is second project, number 2.
Yes, just one second.
Yeah, it is above here, if you scroll up. So there, my suggestion to you had been, in this one, if you can go to the hand-drawn sketch, particularly for our younger colleagues, the students here, the one behind,
Yes.
here. If you see the red color part, which is your intervention, earlier, before this intervention has been made, that reinforced concrete beam is a continuous beam. So at the center span, it will have a sagging bending moment, and reinforcement has been provided according to that. With this intervention, the bending moment pattern changes, and accordingly we have to take into account as to how that intervention is going to affect the original structure.
So
That
basically,
we have to
yes.
inform to our younger colleagues.
Yes, yes.
I'm sure
Okay.
you have taken that into account.
Thank you, sir.
But our younger colleagues must be aware that whenever we are doing this intervention, the original behavior and reinforcement provided should be not overlooked into.
Yes, yes, that is very true. Sir is like taking care that once we are modifying something, so the original behavior should not be ignored, basically.
Yeah,
Thank you.
because
Thank you,
the
sir.
reinforcement pattern as well as stiffness is also changes. So
Yes.
lot of sometimes earthquake forces are attracted towards the area where you have strengthened. So you have to be very careful.
Thank you, sir. Thank you, sir.
Yeah. Any other question from anywhere?
Bracket that you have used, which was not earlier, you can elaborate a little more, because the bracket that is a tapering, and you can elaborate a little more about your design concept.
So basically, there is a overhang bracket of certain size. So what we did, the capacity of that bracket has also some limitations, but definitely we checked that with the drawings, the bracket capacity is not a big problem, because the length is too short to take care that of 25 ton or 50 ton. But still, if we are adding one support to the from bottom, so in that case effective length is basically reducing. So with reduction of that effective length of this cantilever portion, it was adequate at that time. It's a deep beam, yes. Yes, yes.
So Corbel.
Shear, yes, yes.
Yeah, so I think if there are no more questions, we can thank Dr. Yadav for this excellent presentation. Thank you.
Thank you, Mr. Alok Bhaumik, for chairing the session, and to all our speakers for sharing such valuable insights from practice and research. I would request Mr. Jayant Kumar to kindly felicitate Mr. Alok Bhaumik.